Good morning, fifth hour, or it's actually afternoon for you. It might be 8 something morning for me, but you're seeing this fifth hour. We're going to be doing lesson 3 today, so please turn your workbooks to page 455. 455, please. We're going to be doing rotations. Pretty obvious. We're going to be rotating those shapes, usually about the origin, but the book goes, quite a few of the first examples were rotating about 1 point, but in Alex, we're going to be rotating amongst the origin. They first talk about a Ferris wheel, thinking about a Ferris wheel. Maybe you've been to the Shields indoor one. Obviously, you know everything rotates about the very middle, called the eye. If we were to make this into an X and Y coordinate, you'd see your Y, your X. If this was to rotate around, what would it look like? Well, if this triangle is right now here, we need to describe what kind of rotations we're going to be doing. So we can do a 90-degree clockwise rotation going this way as the clock goes. So hopefully you understand that, because we're going to talk a lot about clockwise or counterclockwise. If we went a 90-degree clockwise, obviously if you have a clock, the clock goes around this way, so that's called clockwise. You could also do 180-degree. Now, that one wouldn't matter if you were clockwise or counterclockwise, because either way, you're going to go halfway across. Whether you're going this way or you're going that way, you'd end up in the same place. And then we could have a 270-degree clockwise, where you end up going from here. Let's say this is the line I'm pulling. I go 90, 180, 270. So this Y line ends up facing that way, 270 degree. And this is all clockwise. So we could talk clockwise. We could also talk about counterclockwise. Obviously, a counterclockwise would go the opposite way. And we'll talk about how they're the same. Like a 90-degree clockwise is the same as a 270-degree counter. That's a terrible word, counter. But counter. Those would be the same. 180 is the same both ways. If I went 270 degrees clockwise, that's the same as a 90-degree counter. And we'll talk about that today, and where the actual coordinates end up going. The center rotation, again, Alex will have us turn about 1 point just to show you what that shape would look like, but we're going to normally be rotating about the origin. The rotation, we need to figure out which way it's being turned. Is it clockwise? Is it counter? Is it 90, 180? We need to figure out what the rotation will be.
The graph shows triangle ABC with vertices at A, 4, 5, B, 6, 8, and C, 6, 5. A rotation is a transformation that turns a figure around a fixed point called the center of rotation. In this case, vertex A will be the center of rotation. Rotations can be described by direction. A clockwise rotation turns to the right. A counterclockwise rotation turns to the left. Rotations can also be described in degrees. For example, a rotation can be described as 90 degrees, 180 degrees, or 270 degrees. Rotate triangle ABC 90 degrees clockwise about vertex A. Vertex A is the point at which triangle ABC is rotated, so A' will be in the same position as A. Point B is rotated 90 degrees, and point C is rotated 90 degrees. Next, let's rotate triangle ABC 180 degrees about vertex A. In this example, we will rotate counterclockwise. Since vertex A is the point at which triangle ABC is rotated, A' will be in the same position as A. Point B is rotated 180 degrees, and point C is rotated 180 degrees. Finally, let's look at an example of a 270-degree rotation. Rotate triangle ABC 270 degrees clockwise about vertex A. For each rotation about vertex A prime will be in the same position as A. Point B is rotated 270 degrees, and point C is rotated 270 degrees.
Okay, so you get an idea of what that would look like turning about one of the vertex or vertices. If this line was going to be rotated 90 degrees clockwise, a good way to think about it is if you were going to take the entire piece of paper and rotate this 90 degrees, what would it look like? So once you would see that, now you would know which way it's going to face, which way faces, like on a triangle, which way it's facing which way. It does help to even turn the paper and then kind of get a visual of where it would be, like what quadrant. We haven't talked a lot about maybe numbering the quadrants. We did it earlier this year. If you were just wondering, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4 right there. So you can kind of see what would happen if I rotated this 90 degree clockwise. I'd end up be right there. What would this line look like? So if you just turn your whole paper, you can kind of see what it would look like and what quadrant they would end up becoming. Let's do a couple examples. So this person, I don't really like this example. They're moving a desk, and then you see the desk is in the corner. They want to do a 180 degree rotation. But what I don't like is in this picture, it's like in the corner of his room, but when they go to draw it, they put it on the corner plane. Okay, great. So we're just going to go through and kind of show what it would look like. I don't really like this example. Again, they're showing with a protractor how you could end up moving it. We don't need a protractor to do it. When we're going to do it, there's a really nice feature on Alex to actually drag one of our axes around, and it works out pretty nicely. Okay, so we can do this one. Triangle JKL has the vertices of 3, 1, K is 3, -3, and L is 0, -3. Graph the figure and its image after a clockwise rotation of 9 degrees about vertex J. Now, I could go through and they want you to actually graph this on a piece of paper. I'm going to show you the next example to show you what happens to your XY when you do a rotation, and then in the back of the room, you can look at what I have written for how to get there, which will make it a whole lot easier. Again, maybe you started on a note card. If you have not, I will have a stack of note cards up in the front of the room to the right of the bend cube. Feel free to come up and grab a note card. Maybe you want to add the reflection, how to get there with an x-axis reflection, y-axis reflection. Then you want to put on their rotation. And we're going to have 3 different kind of rotations written on this note card too. So you can easily look at it, and then you'll start to probably memorize them, because next will come dilation. So it'd be nice to have a little note card with everything and what to do. Let's take a look and I'll show you what I mean. Okay, so I'm going to reset this. If we are going to rotate this triangle 90 degrees clockwise, they already have the coordinates on there. They're saying that C is at 8, 8, D is at 6, 2, and E is at 8, 6. If I'm going to rotate this 90 degrees, this shape is going to spin. Again, we're doing clockwise. It's going to rotate around this way. Try to visualize what would that look like when it comes down here. Like, which way would this point? Right now it's kind of pointing this way. Which way do you think it would point? When we actually look at it happen, it should show us. There we go. Notice how that C was pointing up and to the left after a 90 degree rotation. So this whole thing moves 90 degrees. It's pointing that way. But look at the coordinates. How would you describe this? C was 2, 8, and now it's 8, -2. How do you go from these 2 points to these 2 points? What happened? Think of it as we had an X, we had a Y. What did this become? Notice how my 8 was my Y, but now 8 is my X. So I'm going to say this is going to go to Y, but now look at my X. My X was 2, now it's -2. That's the opposite. So we go to the opposite of x. Does that hold true for all three? This was 6, 2, so my x was 6, my y was 2. When we do a 9-degree rotation, now it becomes my y becomes my x. So my y becomes my x. Yes, that held true. My y is now my x. My new y becomes the opposite of x. Well, this was 6, now it's negative 6. Yes, it held true again. How about e? My x was 8, my y was 6. It becomes where my y becomes my x. And my y is the opposite of x. It worked again. So in the back of the room, you will see that for a 90-degree clockwise rotation, it goes from xy to y opposite of x. Showing the same thing again, just rotates it 9 degrees. Now let's see what happens if we did, what's the same one? There you go, the 180. If I'm going to do a 180 degrees. Right now, think about this as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you're going to do a 180-degree rotation, what quadrant do you think this triangle would end up in? 180. Yeah, think about if you were to spin in a circle, maybe you watch the Olympics skating, maybe like snowboarding, where you end up doing rotations, right? So if you think a full circle, we know is 360 degrees. If we're going to go a 180, that's halfway around. Well, if this is over here, what would be like in the exact opposite 180-degree rotation? We should end up in quadrant 3. Let's see if that works. I need me to use my mouse. (180) spins all the way around. Now, let's compare the xy to the image xy. So let's look at pre-image to image. We go from C to C prime. It goes from my x, y, and it ends up going to what? What do you notice happened to both the x and the y? Everything became the opposite. I mean the exact opposite of everything. So these were all positive numbers. These numbers are now all negative. So everything becomes the opposite. So it's simply the opposite of x and the opposite of y. Let's see if that's true for all of them. It was 8, 3. Now it's the opposite. Negative 8, negative 3. Everything became the opposite. What about e? E was 7, 6. It now becomes negative 7, negative 6. It works again. So again, you should probably have that on your note card. It's in the back of the classroom where my xy goes to the opposite of x and the opposite of y. Now, so far, we have the 90-degree clockwise went from x, y, to, hopefully this is still on the screen, to what? Do you have it written down? We have the y opposite of x. We had 180 degree. Now that doesn't matter if it's clockwise or counter because 180 is 180 either way. Now, you have to think this 90 degree clockwise is also the same as a 270 degree counter like we said. So you only need to really write them down one each because this is the same as that. What do you think? So the 180 ended up going from x, y to the opposite of x, the opposite of y. What do you think a 270 degree rotation will give us? 90 ended up going y opposite of x. 180 opposite of x, opposite of y. What do you think will happen for 270? Without seeing it, what do you think will happen? Maybe even jot something down in your book of what you think it will be. You see what happened on the 90. what do you think will happen on a 270? Let's see if you're right. Okay, let's check it out. Okay, we went from our x, y, what happened to it? It went from 2, 8 to a negative 8, positive 2. What happened? My y becomes my x, but it's the opposite. So it's the opposite of y. My new y becomes the original x, which is basically the exact opposite of this one, right? So again, back of the room, I have all this written, where when you do a 270 degree clockwise, your xy becomes, your new x is the opposite of what y was, and your y becomes what your x was. See if it's true here. It was 6, 2. Well, now my new x is the opposite of what y was. That's the opposite of this one, which is, yes, a negative 2. And my y becomes what my x was. Let's see about e. E, 8, 6. Again, the 6 was my y. My new x becomes the opposite of that. Yes. And my new y was my x. There it is. So again, having that written down with the words probably 270 degree and know that these are all clockwise, then you could write what the counter to that would be. A 90 degree clockwise is a 270 counter. 180 is the same either way. A 270 degree clockwise is the same as what? A 90 degree counter. So you might want to write that down there, because in Alex, they might say counter one time, the next question might say clockwise. So knowing that these are the same will help you out there. So we went from x, y to the opposite of y, x. Okay, let's try some examples, knowing what we have here. Nine-degree rotation, just examples of it. We went from x, y to y, negative x. You see what happens. If we go 180 rotation, we go from x, y to the opposite of x, the opposite of y when we do our image. And 270, when we just did, we go from x, y to the opposite of y, x. And knowing these will be a whole lot easier than trying to visually do it. Trying to visually just see where it's going to go is very tricky. So again, this should be something you probably write down, and then add on there that a 90 degree clockwise is the same as 270 counter. 270 clockwise is the same as a 90 counter. Having this stuff written down, again, we can always share this video with you later. You can pause it, look at this, but it's also right in your book. So what if they don't give you a coordinate plane to work with? Well, that's okay. We have the notes for it. What we're looking at is this triangle with these coordinates, and I'm doing a 90 degree clockwise. So it really helps, maybe even on your screen with that red ink, write down what you do. The more often you write it, the better chance of you remembering it. If I'm doing a 90 degree clockwise, what was the x, y? What does it become? Maybe look at your notes real quick, see if you can remind yourself, what is a 90 degree clockwise rotation? We go to y and the opposite of x, right? So now let's do that with the numbers. So my d was negative 4, 4. What would d prime become? My y becomes my new x. So that's 4. My new y is the opposite of what x was. Well, if this is a negative 4, what's the opposite of that? A positive 4. So the prime, or the image of it, would become positive 4, positive 4. How about e? E was negative 1, 2. what would this become with d prime? Again, my y, or my y here, ends up becoming my new x. So my 2 becomes my new x, and my new y is the opposite of what x was. So what's the opposite of a negative 1? A positive 1. Why did I write d again? This should not be d. Apologize for that. This should be e prime. Now I'm going to go f. So here's f. I go from negative 3, 1. I'm going to become f prime. My new x was y, 1. My new y is the opposite of x, so that should be a positive 3. So we can do it without coordinate plane by knowing the little formula right there. Okay, I just did all that in the previous page. How about this one? Triangle ABC has vertices A, B, and C. You can see their points. The triangle is going to be rotated 270 degrees clockwise about the origin. Write the new coordinates. So how do we change on a 270 degree clockwise? What we're going to do is we're going to put that formula right there. If we do a 270 degree clockwise, we go from xy to the opposite of y, x. So if I go down here to write the new a, or a prime, if I was at a 4, negative 4, 1, I want to take my new x will be the opposite of what y was. What's the opposite of 1? Negative 1. And then my new y becomes what x was, a negative 4. How about b? b was a negative 1, 4. Again, I want the opposite of what y was. So since y was 4, I want the opposite of that one, negative 4. For my y, it is going to be your x, which is negative 1. Let's put c prime over here. Can I run out of room? C prime. Now c was at a negative 2, 1. I want to take the opposite of what y was. The opposite of 1 would become negative 1. And my y is what the x was, negative 2. Using coordinate rotation, describe the rotation. What if they asked you to figure out what kind of a rotation happened? Couple ways. You could take your paper and see, was it a 90, was it a 180, was it a 270? Or you can look at what happened to a single point. Let's just look at how about B. Now, I'm going to look at what happened from the original to the new. If I go and look at B, B is at a negative 1, 2, 3, 4, 5. So B is at negative 5, 1. B prime is 1, 2, 3, 4, 5, negative 1. What happened with these 2 points to go to these 2 points? The x, y became what? The opposite of x and the opposite of y. What rotation tells us that? 180 degree rotation. Clockwise or counterclockwise, doesn't matter, they're the same. Okay, that's all I wanted to show in the book. Now let's get to your Alex assignment and show you what I'm talking about here. I only have a few minutes before the class comes in, so it might have to be a second video coming up. 8.3. What I'm going to do is I'm going to stop the recording. I only have like 3 minutes until my next class comes in. I'll make a separate video for the Alex one that you can click on, so it'll just be titled 8.3 Alex assignment.